Welcome to another tutorial of Proflearn YouTube channel. In this particular video, we're going to have a discussion of CIE Pure Math 3, that is code 9709 stroke vape merge, that is 2025. So we're going to look at the questions that really made most of the students cry when they were in the exam room, and when they came out also they were lamenting about those particular questions. So the first question that was tested in this exam, this is the question of solving natural logs, and you can see here the candidates was told to solve ln into 1 minus e is to negative 2x plus 3 is equals to 0. So the first thing that we were supposed to do, all the students who were supposed to do in that particular exam, is to take the constant 3 on the other side of the equal sign. So these students were supposed to take 3 on the other side, and then we're going to raise to e both sides, because anytime you want to remove the natural log, you introduce e both sides, and you can see now this becomes ln will cancel out. We're going to remain with whatever that was inside the bracket, and we shall have e raised to power minus 3. With that, now we can be able to rearrange so that we can be able to have e is to negative 2x, and then we shall introduce ln again both sides so that we can be able to get rid of the exponent. And if we do that, we are going to, if we introduce ln both sides, the power is going to come down, and then we have ln e, and ln e is 1. So divided by negative 2 both sides, we're gonna remain with negative 1 over 2 ln of into bracket 1 minus e is to negative 3. And if we can put that into the calculator, we are going to get our answer being equivalent to 0.0255 as the answer in that case. If you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to upload part 2 of this tutorial, you'll be notified. So we need to go further to the next part, whereby we were supposed to work out and get to see what is really expected in the next question, which topic was tested in the next topic. The next question was equation of this is implicit differentiation that was being tested here. You are given the equation of a curve, which is xy squared plus ln x plus 2y is equals to 1. So this is where you are going to apply implicit differentiation. You are not going to rearrange this in any way for you to work it out. You work it the way it is. So if you are having xy squared, it means this is a product of two functions. Then you are going to use product rule in order to differentiate this. So for us to apply product rule, we are going to keep, for instance, here we're gonna keep y squared constant. We differentiate x, and if you differentiate x, you are going to get 1. That's why you see we're having 1 y squared. Now in the second case, we're going to keep x constant. We differentiate y squared, and if we differentiate y squared, we're going to take the power down. We shall have 2y, but we shall have an x there because x we kept it constant. And since we differentiated y, then y is a function x. Remember, you have to write dy dx anytime you are differentiating y. We are having also a scenario whereby we're supposed to differentiate ln of x plus 2y, but this one is in bracket. Then now we see whenever you are differentiating a natural log, you take the expression that is inside the bracket, you write it over, so everything over that, and then now we are going to differentiate whatever that is inside. So we shall say everything over x plus 2y. Now we shall differentiate. If you differentiate x, you get 1, and if you differentiate 2y, we are going to get 2, but since we are differentiating a y function, which is a function of x, we shall write dy dx at that point. Differentiating 1, you'll get 0 there. So once you have done that, you are going to put those terms with dy dx together and those terms without together, like this, the way I did. And with that, now I decided to take all of this on the other side of the equal sign. Since everything here was a positive, then you can see I'm having a negative at this given point. So if I divide all of this both sides, we shall have this. Since we are looking for a scenario whereby we are finding dy dx, but remember, this dy dx is a function of x and y, then we need also to know what y is, because already we were told the value of x in this was what? X was equals to 0. So if we substitute x equals to 0 into this original equation, we can be able to get the value of y. And that is exactly what I did at this given point. When I substituted x equals to 0 to the original equation, I got the value of y to be y equals to 1 over 2 is to e. And then now I can be able to find dy dx, which is the gradient of the curve. And in that function of dy dx that we are having here, I'm going to substitute x is equals to 0, and also I'll substitute the value of y which we have gotten, which is y equals to e over 2. If you substitute and work it out faithfully, following all the steps without mixing anything, you are going to get your answer equivalent to negative e over 2 into bracket e is to 2 over 4 plus 1 over a. Then you can be able to open the bracket and you're gonna get your answer like that. So I was looking at question that really made most students cry in that exam room. One of the question also that made student cry is the question of trigonometry. And here you are told by first expressing the equation tan x minus 60 equals to 2 cot x as a quadratic equation in tan x, solve the equation for x greater than or equals to 0, less than or equal to 180. So the first thing that you were to remember in that exam for you to avoid crying is this identity for tan a minus tan b. So if you were in a position to remember that, no crying in the exam room. Then we are to say tan a minus b is usually equals to what? Is usually equal to tan a tan b is usually equal to what? Let's check. What is it equals to? This is equals to tan a minus tan b over 1 plus tan a tan b. That is what we were supposed to remember that given point. So we are going to rewrite this equation that we were having at the top here with this trigonometric identity that we are having. And also this student was supposed to remember that 2 cot x is the same as 2 over tan x. So substituting that and putting tan 60 is going to give you square root of 3. And if you expand this, you are going to have your answer for the being a quadratic in terms of tan x as tan squared x minus 3 root 3 tan x minus 2 is equals to 0. And then you are supposed to solve that. We can let tan x be m. Now we are going to form a quadratic equation. M squared minus 3 root 3m minus 2 is equals to 0. And if you work it out, you are going to get the value of m being equivalent to 5.5561 and another value of m being negative 0.35996. So once you have gotten that, you are supposed to solve for tan x, because we are at the end of the day, what we want to find is what is the value of x, what are the angles that satisfy those trigonometric equations. So we are going to say tan x is equals to 5.55. This is where tan is positive. Tan is positive in the first quadrant and in the third quadrant. So at that point whereby you need to find x, you are going to find the tan inverse of that angle, and that becomes 79.8 degrees. But for the second one, because you see, if you go beyond that, you'll be out of the range. So if you measure this angle up to this other third quadrant, you'll be out of the range. So in that case, we're going to take 79.8 as one value of x. The next one is where tan is negative, and tan is negative in the fourth quadrant and in the second quadrant. So first we're going to find tan x is equals to that, then tan inverse of this is going to give a negative 19.8. so anytime you are getting a negative angle, it means you are going to read that below the x-axis, so that angle is going to be placed here. If you got it positive, it will be above this positive x-axis. So that's why we're having 19.8, and because of symmetry, if this angle is 19.8, this angle on the other side also is 19.8. So for us to find positive angle, we are going to measure from the x-axis up to this particular point, and that is going to be 180 minus 19.8, which is going to give us 160.2, and the student got that. So there are two answers we were supposed to get at this given point, that is 79.8 and the 160.2. and if you knew the trigonometric identity of tan A minus tan B, you could not cry in that particular exam of VEP March 2025. If you are new to Proflearn YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be in a position to get the notification so that you can be able to continue learning math and physics from Proflearn. And also, if you're finding value from this particular video, consider sharing and recommending this video to your friend, and encourage them to also to subscribe and join the Proflearn family. Let's move to the next question that gave most of the students hard time and heart attack during the exam, and the question was from complex numbers. And some of those students forgot how a square root of a number works. Now you are told the square root of negative 4 plus 6 root 5i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. So in that case, by first performing the quadratic equation in x and y, find the equation, find the square roots of this in exact Cartesian form. So the first thing this student who cried in this exam could remember is that if this is indeed a square root, it means that if you square this number, you are going to get this number that you are told this is a square root. Basically, you take x plus iy squared should give you that. Then once you expand this, you are going to get x times x times x will give you x squared. X times iy will give you xiy, and again xiy, so we end up having 2xyi minus y squared, because I times I will give us -1. That's basically, I believe you know the basics of multiplying complex numbers, and then we can be able to say it's equals to -4 plus 6 root 5i. So once this student had gotten that value, then he was supposed to collect those terms, which are those real and imaginary numbers together, put them together so that you can be able now to compare imaginary and the real part of this complex number. So in this case, we are going to collect x squared minus y squared. This is the real part, and 2xyi is the imaginary part. Then at that given point, we can now relate, since since this part and this part are equal, then it means also the real part and the real part on the other side should be equal, and the imaginary part should also be equal to the imaginary part. So we can say x squared minus y squared is equals to -4, and also 2xyi is equals to 6 root 5i. Then I and I will commit suicide, so that we are going to have our equation as 2xy is equals 6 root 5. once you have this, you can be able to make x the subject of the formula, so that we can be able to substitute anywhere we have x in this part, so that we can be able to form a quadratic equation the examiner was talking about. So since we were having here x squared, and we have said x is 3 root 5 over y, if we square this, we can be able to get 45 over y squared. Then it means for us to get rid of this y squared from the denominator, we're going to multiply through all the terms by y squared, and then we're going to have 45, because this one and this one will cancel out, and then we're going to have 45 minus y power 4 is equals to negative 4y squared. So if we rearrange this question, we are going to have a quadratic equation, which is 4 raised to power y raised to power 4 minus 4y squared minus 45 is equal to 0. Now this is the quadratic equation the examiner was talking about, and something that you really need to remember is that a quadratic equation is the equation with the highest power being 4. Then now, once you have identified that, the way you solve a quadratic equation, you can now decide and come and let whatever equation that we are having here, which is in this quadratic equation that we are having here, anywhere that we have there, anywhere you have y squared, you can let it to be equal to m. So y raised to power 4 becomes m squared minus 4m minus 45 is equals to 0. So that is basically how we're going to solve that, because we must have now formed a quadratic equation which we are quite familiar with as far as our life in pure math is concerned. So if we are going to solve this quadratic equation that we are having here using a quadratic formula, we are going to get m is equals to 9 and m is equals to negative 5. So but now with this m equals to negative 5, we are going to drop it on arrival, because there is no way a number can be squared you get a negative number. That does not exist. So we are going to say, therefore, our m that we are going to put into perspective and consideration and accept here and embrace is m is equals to 9. And now we can be able to take y squared is equals to 9, finding the square root both sides. We are going to get y is equals to 3 or y is equals to negative 3. Now upon doing that, we can be able to find out the value of y. When y is 3, what is the value of x? Because remember, we had said let our x be equals to what? Let our x be equal to 3 root 5 over y. So where you have y3, you shall substitute here. When you are having y equals to negative 3, we are going to substitute there, and then we shall have our first value of x is going to be root 5, and the second value in that case, let me just go back. So therefore, if x is y is 3 and x is root 5, then our root becomes 5 root 5 plus 3i, because y is on the imaginary part, right? So the first root is going to be root 5 plus 3i, and the second root in this case is going to be minus root 5 minus 3i, because in this case now our x is going to be minus 5 and our y was minus 3. And I believe now you've gotten value on how to work such kind of questions. Now the next question that made students cry seriously is the question on differential equations. How to solve differential equation. And most students think that differential equation is basically differentiation. No, differential equation is basically integration. If you have a good foundation in integration, then you can be able to shake the questions of differential equations in an exam of pure math 3. Now in this case, we are told the variables theta, x and theta, the variables x and theta satisfy the differential equation that we are having here. So this is the differential equation that we are having, and then we are supposed to do what? to work out. So to solve the differential equation and express it in terms of x and theta only, it means we are going to go into details and separate the variables. So how do you separate the variables? You see here we're having dx and the theta. So we have to ensure those terms with x and the dx are one side, and those terms with theta and the theta are on the other side. So in this case, I'm going to divide this guy that I'm having here. I divide this guy that I'm having here both sides and multiply the theta both sides. And then upon separating the variables, I'm going to get 1 over 1 over 5 x plus 1 dx is equals to sine squared to theta d theta. So that is the first thing we were supposed to do in order to work out this question. The second part is to perform now the integration both sides. How do you integrate this? Since this is a fraction, then we are going to introduce natural log both sides. We are going to introduce natural ln both sides. When you integrate, what am I saying? When you're going to integrate this part, because it's a fraction, then we're going to introduce ln, and then we are going to say ln of whatever we are having here. Then once you have introduced the ln, you are going to divide everything by what you get when you differentiate what's inside the bracket, the fraction inside the bracket. So whenever you are basically integrating, if you are integrating 1 over f of x with respect to x, we usually say this becomes what? Ln of f of x, then over derivative of f of x. So that means you'll say ln of whatever that we were having down here, and then differentiate whatever we have inside, we divide it. So if you divide 1 over 5, it becomes 5. So the other part that we are having that is quite interesting, this part here, but remember in P3, in Math 3, we have not learned the technique of integrating sine squared. So we are going to use double angle in order to be able to express that in terms of cos 2a equals to 1 minus 2 sine squared a. So using this identity, we can be able to transform this sine squared theta to theta into something we can be able to integrate. So if we can be able to transform that, this is exactly what we are going to do. If you change that, we are going to have, you can say, if we can divide all 2 by 2, we can say this is 1 over 2 cos 2a is equals to 1 over 2 minus sine squared a. I can bring this on the other side and have sine squared a is equals to 1 over 2 minus 1 over 2 cos 2a. So anywhere I was having a, whenever I'm going to replace it on the other side, I'll put 2a here. So that's why you can see I'm having 1 over 2 minus 1 over 2 cos 4 theta, because our a in this case was 2 theta. Since this is 2 times a, then therefore we shall have 4 theta in that particular case. So at this given point now, we can be able to integrate. You can integrate this term, you can integrate this term with respect to theta, and integrating a half, you get a half theta. Integrating cos 4 theta, remember you are going to first differentiate 4 theta, you get 4, you divide it whatever we're having here, so we shall have 1 over 2 times 1 over 4, that becomes 1 over 8, and then integrating cos, you get sine, so we shall say sine 4 theta, then plus c. We were told that x is equals to 5 and x is equals to theta. Now that we already have the conditions that boundary condition here, we have x is 5 and theta is 0, we can be able to substitute inside here so that we can find the value of c. Now I decided to change the trajectory, so I'll be working up there because a lot of space was required. So in that case, we are going to substitute everywhere we have and if you now substitute anywhere you have x5 with 5 and anywhere you have theta with 0, you are going to have your c being equals to ln of 32. So with this value of c that we have gotten here, we can substitute it in the equation that we had written at this given point, this equation that we had gotten here. So we are going to substitute anywhere you have c, you are going to write ln of 32. So since this question we were supposed to express our answer in terms of x and theta only, then we are going to figure it out so that we can be able to get rid of this x from inside the bracket so that we can be able to have our equation in a proper manner. Then we shall introduce e both sides so that we can get rid of this ln. So if we introduce e here, the ln is going to disappear. We remain with 1 over 5x plus 1 raised to power 5, and we shall say that is going to be equals to the all of this equation that we are having here will be raised to e, right? Now multiplying both sides by 1 over 5 power 1 over 5 so that we get rid of this power here, then we shall have our equation reducing to, of course, this and this will cancel out, so that we shall have 1 over 5x plus 1. And if we multiply all through those powers, and something I need to mention is that you see this is an exponent, we are having this plus at this given point here, yeah? So we can be able to split this and say we can write it as what? We can write it as e is to 1 over 8 theta. Let me check whether you can be able to see exactly what I wrote here. This is 1 over 8. This, don't confuse, that's 1 over 8 there. So if you multiply, you see now that expression can be written as e is to 1 over 8 theta minus this is 1 over yeah, so let me just write this so that it can be a bit visible. So this is 1 over 2, and then we're having 8 here. Basically this is 1 over 2 at this point, and this is 8 at that given point. So therefore, if we multiply all through by 1 over 5, we are going to have 1 over 10 theta minus 1 over 40 sine 4 theta times e is to 1 over 5 ln of 32, whereby we can be able to take 1 over 5 on top here to be 32 raised to power 1 over 5, and that's going to reduce to 2, which we're going to see down here, have it down here. So we are remaining with 1 over 5x plus 1. Indeed the question was long, but that is how we're gonna go about it. Is equals to is to 1 over 10 theta minus 1 over 40 sine 4 theta is times e ln of 2, because 32 raised to power 1 over 5 is going to be 2. And this one, of course, e and ln will cancel out, and that's going to reduce to 2, and then we're going to multiply it in front here. Yeah, so if we multiply it in front here, we are trying to simplify quite well things there, and we shall take them, we can multiply all through by 5 so that we get rid of this fraction 1 over 5. So we shall have x plus what, 5 is equals to 10, because 5 times 2 will be 10, is to 1 over 10 theta minus 1 over 40 sine 4 theta. So we are having that, and then we shall take this 5 on the other side of the equal sign, so that we are going to have our answer like that. Check in the description, I have added a link that is taking you straight to the other part of the questions from the next question here, so that you can be able to see how are you supposed to solve this question of numerical analysis. Then it means also you are going to look at how you are supposed to solve question to do with vectors, right? These are the questions that basically made many students cry in that exam, and if you have gotten value, consider subscribing so that anytime I'm going to add more tutorials, you'll be notified. Don't forget to check in the description the next part that of the question, the next part of this paper that made students cry. Remember to check in our Patreon page so that you can be able to get the PDF of all these solutions that I've worked here, and you continue learning. See you in the next video.